Mr. Lum again, and we're going to be continuing on with some Chemistry 11. Last time we talked about what is a mole, and we also talked about Avogadro's hypothesis. And now we're going to be learning how to use the mole and what we can, some things that we can do with it. So anyways, so using the mole. So if you're given a substance and asked to change the unit, often the first step is going to be changing it to a mole. So here's a question right here. It says 10 grams of carbon dioxide, and how many liters of gas does this occupy at STP? Remember in the last video we talked about what is STP, and STP stands for standard temperature and pressure. The standard temperature being 0 and pressure being 101.3 kilopascals. So we're going to be taking these 10 grams of CO2, and if we had 10 grams of CO2, how many liters of gas is that going to occupy? So my first step is I should take my grams of CO2 and I should change it to moles. So as I say in class, when in doubt, mole it out. So we're going to be changing grams into moles. So I'm going to be taking my 10.0 grams of CO2, and I want grams to go away, so I'm going to be putting grams on the bottom, and I want to change it into moles. So 1 mole is equal to the molar mass of carbon dioxide, and so the molar mass of carbon dioxide is, well, carbon is 12, and oxygen is 16. There's 2 oxygens, so 16 plus 16 is 32. And that's 44 grams. So my first step is to take 10 grams of CO2 times by 1 divided by the molar mass, or 44 grams. And now if I just did this unit right here, we would have moles of carbon dioxide, but I don't want moles of carbon dioxide, I want liters of gas. So remembering what Avogadro's number is, or hypothesis about all gases, they all occupy the same space at the same temperature and pressure. So, and that is 22.4 liters. So 22.4 liters is equal to 1 mole of gas at STP. So just to make sure that I'll be doing everything right, and this is kind of a check that you can do, is if your units cancel, then you'll probably have the right answer. So grams cancels with grams, moles cancels with moles, and my unit that I have left are liters of CO2, and that's exactly what I want. I want liters of CO2. So in my calculator, I'm going 10 divided by 44 times 22.4, and I get 5.0909 liters of CO2. Now, all of these things do have sig figs. So 10.0 is 3 sig figs, 44.0 is 3, and 22.4 is also 3 sig figs. So my answer should be in 3 sig figs. So that should be 5.09 liters of CO2. Okay, if you think you know how to do this one, you can put on pause, or you can and then check with me. But we're going to be doing this one, and this one's a little bit different. It says how many particles are in 8 grams of H2O2, or hydrogen peroxide. So if we remember Avogadro's number, it says that there's 6.02 times 10 to the 23 particles is in 1 mole. So same thing, I have 8 grams of hydrogen peroxide. My first step is to change it into moles. Often it's going to be change this into moles. If it's already in moles, it kind of saves you a step, but that's often what your first step is going to be. So I'm going to be taking 8.0 grams of hydrogen peroxide, and I'm going to change it into moles. So 1 mole is equal to, now hydrogen peroxide is, again, this is 2 oxygens, so that's going to be, and that's going to be 32, plus 2 hydrogens, so that's 2, so 32 plus 2 is 34. So 34.0 grams. So if I just did this, I would have moles of hydrogen peroxide. But I don't want moles, so I'm going to cancel out moles by putting it on the bottom, so moles cancels out. And then I want particles, and so I'm going to go 6.02 times 10 to the 23 particles. If you have a hard time setting all of this stuff up, again, what you really need to make sure is that your units cancel out. Okay, grams is on top, grams is on bottom, they cancel out. Moles is on top, moles is on the bottom, they cancel out. And my only units that I have left are hydrogen peroxide and particles. And that is what I want. Okay, so if you have like both times like the moles are on the top, then you know you set up your thing a little bit wrong. So I'm going to be running this thing right here, and then I'm going to do the math on this. And so I'm going to go 8 divided by 34 times 6.02 times 10 to the 23. And I get 1 point, I'm going to change my pen color, 1.416 times 10 to the 23. That's particles of hydrogen peroxide. Now, again, 2 sig figs, 3 sig figs, and Avogadro's number here is also 3 sig figs. So 2 sig figs should be our answer. So it's just going to be 1.4 times 10 to the 23 particles of H2O2. And that's our answer. Okay. Last question. Try doing this one yourself and put the video on pause. And then if not, you can watch me do this one as well. But same thing right here. We have 311 grams of C2H6 or ethane, and so our first step is going to be finding the molar mass of C2H6. So we have 2 carbons. Each carbon has a molar mass of 12, so that's going to be 24. Okay, and we have 6 hydrogens, and so 6 hydrogens is the molar mass of hydrogen is 1, so that's just going to be 6. 24 plus 6 equals 30, and so the molar mass is 30. So now I'm going to be starting this and going 311 grams, and I like to write my C2H6 as part of my thing. And I want grams to cancel out, so I'm going to be putting grams on the bottom. 1 mole, and the molar mass of ethane is 30. And now I have, if I just did this calculation, I would have moles of ethane. And so now I want moles of, I want liters of ethane. So I want moles to cancel out. So I'm going to put 1 mole on the bottom, and I'm going to put 22.4 liters on the top right here. If I want to make sure that I have the right units, I'm double check, make sure everything cancels out. So my grams cancels out, my moles cancels out, and the only things that I have left are ethane and liters. So, and that's what I want. So I'm going to type this into my calculator and go 311 divided by 30 times 22.4 equals, and I get 232.2 liters of ethane, C2H6. Okay, again, 3 sig figs, 3 sig figs, 3 sig figs, so my final answer should be 3 sig figs. So I'm going to shorten this down to 3 sig figs, and that's going to go down to 232 liters of ethane.